we are going to talk about homogeneous equation. Okay, so this is still under the topic solutions to first order differential equation. Now this method of solving differential equation is it involves transformation of the variables. So we have two cases here. The first one is those equations with homogeneous coefficients or the homogeneous differential equation, which will be our topic for today. And the next case are those coefficients with um, um, linear coefficients in two variables. So let's focus first on the homogeneous differential equation. Let us first get to know homogeneous. Let's um, learn about homogeneous functions. So before I give you the formal definitions, let me present to you 5 examples of homogeneous functions. So here we have the first 3 examples being obvious homogeneous functions. So these are actually polynomials, homogeneous polynomials to be specific. Um, so why are these functions homogeneous polynomials? So take a look at each term. So as you can see, the degree in each term are the same. So having the degree or having the same degree in each term makes this polynomial homogeneous polynomial. Okay, so let's take a look at this example. So x squared, so this term has degree 2, second term 3xy. So take a look at the variables here. So we have degree 2. And for the last term, we have y squared, also degree 2. So this makes this function homogeneous, degree 2. Again, so a homogeneous polynomial is a polynomial contain or having or the same degree in each term. Okay, so just like the second example, this is x cubed plus y cubed. This example or this function is a homogeneous function since the degree in each term are the same. First term is degree 3 and second term is degree 3. And for the third example, we have x raised to 4 times y. So this term is degree 5 and the second term 7y to the fifth is degree 5. So if the degree in each term are the same, they are, or this function is considered homogeneous polynomial or homogeneous function. So I mentioned earlier that the first 3 examples are very obvious, or you can actually, by just looking at the given function, you can easily determine whether or not that function is homogeneous. But the last 2 examples here, number 4 and number 5, you cannot easily determine whether these functions are homogeneous or not. Okay, so we have the formal definition of the homogeneity of a function. So we will apply this definition in evaluating number 4 and number 5. So why these functions, number 4 and number 5, are homogeneous? When in fact, by just looking at the given functions, you cannot directly say that these are homogeneous functions. So the formal definition states the function f of x and y is said to be homogeneous of degree k in x and y if and only if the function lambda x and lambda y is equal to lambda raised to k times the given function. So again, we utilized here the Greek letter lambda. Let me just type it in here. So this symbol, Greek symbol, is lambda. In other books, they use letter T. They introduce letter T instead of lambda. So in here, we replaced x by lambda x and y by lambda y. And if it happen, if we can be able to factor out lambda, okay, in the given function, okay, that function is homogeneous. So let us try to evaluate example number 4 and number 5, applying the formal definition of the homogeneity of a function. Okay, wait for a moment. Okay, so let's take a look at this function. Now, the instruction here is determine whether or not the function is homogeneous. If it's homogeneous, state the degree of the functions. Again, we know that this is a homogeneous function from the previous example. So let's just prove that this is really a homogeneous function and will determine the degree of the function. So what we will do here is we are going to replace x by lambda x and y by lambda y. So we write first our first term here. So you just copy 2 and y will be replaced by lambda y and raised to the power 3. So this becomes lambda cube times y cube. And this function here, e raised to y over x, we will replace y by lambda y and x by lambda x. That's why we have this term. And for the second term here, the numerator is x raised to 4, so replace x by lambda x. So you have the quantity lambda x raised to 4 or lambda raised to 4 times x raised to 4 divided by your denominator is x. This becomes lambda x, and you add 3y or 3 lambda y. Now, our next step is we will factor out lambda. If we can be able to factor out lambda from the given or from this function, and no lambda is being seen in the function, I mean, the original function, then that is a homogeneous function. So as you can see here, we can factor out lambda cube. And in this exponential function, you can cancel lambda, right? Because lambda y over lambda x. So just think of lambda as another variable being introduced here. So you can just cancel lambda and you have e raised to y over x. That's why we have lambda cube in the first term. So we put a grouping symbol here. And for the second term, we have in your denominator, so you have a common factor, and that is lambda. So you can factor out lambda here, and then you divide lambda raised to 4 by lambda, and that we have lambda cube in this term. So as you can see, we have a common factor, which is lambda cube. So you factor out now lambda cube, and we have, of course, lambda cube times the original function, which is 2y cube e raised to y over x minus x raised to 4 over x plus 3y. Okay, so you were able to factor out lambda, and yes, there's the function is intact. So this lambda will help us determine the degree of the function. So the exponent of lambda is the degree of the function. Now, this is a homogeneous function of degree 3 in x and y. Okay, now let's examine the last example, which is x over square root of x squared plus y squared. So as you can see, okay, we don't know if this is a homogeneous function yet. So we will apply what is being said in the homogeneity, in the formal definition of homogeneity of a function. So we are going to replace x by lambda x and y by lambda y. So applying it in here, so you have lambda x in your numerator and in your denominator. So you have the square root of, so x becomes lambda x raised to the power 2 or lambda squared x squared. And for y squared, this becomes lambda squared y squared. So as you notice, you have a common factor here in your denominator, and that is lambda square. So we factor out lambda square inside the squared symbol, and then take the square root. So we have lambda. Okay, square root of lambda squared is lambda, and that you have here part of the original function square root of x squared plus y squared. Now, what's next is that you can see you have lambda in your numerator and you have lambda in your denominator, so you can cancel this. So you were able to eliminate lambda there, or having no lambda in the given function means that the degree is 0. because any number raised to 0 is 1, right? So that's why for us to be able to determine its degree, so we put here lambda raised to 0 or equal to 1. And this function is intact, okay, x over square root of x squared plus y squared. And this is homogeneous of degree 0. Now, for homogeneous functions, the degree is not limited to whole numbers. So you can have um, integers as degree of the given homogeneous function. So you can have a negative degree, you can have a fraction, or negative numbers. Okay, so it's different from the degree of the equation. So here we're talking about homogeneous functions, and the degree is not limited to whole numbers. Okay, now let's go over these other examples here. Okay, so take a look at this. Square root of x plus y. So my question, is square root of x plus y a homogeneous function or not? If it's homogeneous, then what is the degree of that function? If you're going to apply the homogeneity of the function, where you replace x by lambda x and y by lambda y, if you can be able to factor out lambda from that function and bringing the function into its original form, okay, then that is homogeneous function. So let me just get a pen and apply lambda here if you're not sure. So here, if your function is, okay, function of x and y is equal to the square root of, well, for me, I can be able to determine the homogeneity of the function and the degree, but yeah, for the sake of, you know, applying the homogeneity, so we are going to replace x by lambda x and y by lambda y. Thus, we have this expression lambda x, okay, plus lambda y. So as you can see, lambda is common in each term inside your squared symbol. So you can actually factor out lambda here. And that is, of course, lambda times the quantity x plus y. Or you can actually take the square root, and that is square root of lambda is, yeah, it can be written as lambda raised to 1/2, right? Because square root means a power raised to 1/2. So times the square root of x plus y. So this is the given function that you know, we are to determine its homogeneity, and this lambda raised to 1/2 will determine the degree of the function. So we're able to factor out lambda. That's why this function is homogeneous and degree, homogeneous of degree 1/2. Okay, any question here? Do you follow? I hope so.
Yes po.
So no question here. So this given function is a homogeneous function of degree 1/2. Again, so may I just remind you, the degree of a homogeneous functions is not limited to whole numbers only. So you can have fraction, you can have negative, you can have 0. Okay, how about number 4? Is e raised to x a homogeneous function or not?
Hindi po.
Okay, so this is not a homogeneous. Why? If you introduce lambda here, we cannot be able to remove lambda, right? If we multiply lambda or we replace x by lambda x, we cannot be able to eliminate lambda there. So this is not a homogeneous function. Okay, how about example number 5? ln of x minus ln of y. Is this homogeneous or not?
Homogeneous.
Okay, homogeneous. Okay, so let's try to apply lambda here because you said it's homogeneous. So if we apply lambda, we can be able to factor it out inside the given function. So let me just get a pen. Okay, if our given function is this ln of x minus ln of y. If we apply now lambda, replace x by lambda x and y by lambda y. So this is ln of lambda x minus ln of lambda y. Okay, so how do we remove lambda here? We can actually utilize the property of logarithmic function here where if it's minus, so the argument becomes the ratio of the arguments. Okay, the numerator will become, okay, for the first term. So this first term will be the argument lambda x over, okay, the second term with minus is the denominator in your argument. So lambda y. So by rewriting this function into this form, we can be able to cancel lambda. That's why this is lambda x over y. Since there's no lambda there, the degree of that function is 0. So this is homogeneous degree 0. If I try to, okay, so this is homogeneous of degree 0. Okay. Do you need more examples or are we good here? I think we're good. No response means, yeah, we're good, sir. We can go to the next topic. Any questions? Surely? Okay, so great. Now we proceed to homogeneous equations. Now that we learned about homogeneous functions, now how do we determine whether an equation is homogeneous or not, or if the equations um, have homogeneous functions? Of course, try to recall or be familiar with the definition. Okay, for polynomials, it's easy because you just need to make sure that the degree in each term are the same. Okay. Now we have a theorem here. If m, a function of x and y, and n, a function of x and y, are both homogeneous functions and of the same degree, the function m over n is homogeneous of degree 0. Okay, so try to picture this out. You have m and n, both are homogeneous functions and of the same degree. Then if you are to put it in a ratio, okay, for instance, m has a degree equivalent to 2 and n has a degree equivalent to 2. So you can cancel, right? You can cancel that degree, the lambda raised to 2 over lambda raised to 2. So meaning you don't have lambda anymore in that ratio. So giving us a degree 0, okay, representing that function. Okay, so putting the given functions into a ratio will give us degree 0 since they are of the same degree. Now suppose we have this equation, first order equation, m times dx, okay, plus n times dy equal to 0. And these coefficients, itong functions na to, m and n, are homogeneous function and of the same degree. Okay, tandaan. So if these are homogeneous functions and of the same degree, kailangan the same yung degree nila, then we call it a homogeneous equation. Okay, another way is that kapag kinuha mo yung ratio niya, di ba, m over n, degree 0 yung kalalabasan. That is homogeneous differential equation. Okay, kasi may possibility kasi na homogeneous function yung m, pero magkaiba sila ng degree. Yung n mo is homogeneous din, but kapag kinuha mo yung ratio nila, hindi 0, then that is not a homogeneous function. Okay? Pag nakaganitong format, madali mong ma-determine kaagad. Tignan mo lang yung degree ng bawat term. Pag pareho yan silang lahat, then that equation is homogeneous equation. So say for instance, let me just write something here. Okay, so yeah, x plus y dx, okay, plus uh, x sine of x over y dy equal to 0. Okay, so do you consider this equation a homogeneous differential equation? Anyone?
Yes.
Hey, are you here? So take a look at this. Given equation, x plus y. Okay, let me just, where's my pen? Okay, there's a chat here. Sabi, yes po. Okay, so this is a homogeneous equation actually. So sabi ni Jeremy. So si Jeremy lang may sabi. Tingnan natin kung tama si Jeremy. Mhm. Okay. So tingnan natin, 'di ba, kapag sabi natin homogeneous equation siya kapag coefficients are homogeneous and of the same degree. So here you have x plus y. X plus y is a homogeneous function degree 1, right? So degree 1, degree 1. Para masabi natin na homogeneous equation to, yung itong term na to should have degree 1 din, di ba? I mean, na degree. Dapat homogeneous function din. So ang tanong ba ito ay homogeneous function? If we apply lambda, can we be able to factor out lambda? Yes, kasi 'di ba ratio to x over y. So if you replace x by lambda x and y by lambda y, you can cancel lambda. So tanggal na yung lambda dito and then you put lambda here. So this lambda means that yung degree ng function na yan is 1. So degree 1, pareho sila ng degree at parehong homogeneous functions. Then this equation is a homogeneous differential equation. Okay, clear? I hope so. Let me
Opo.
just clear the drawing. Now, so what happens? So how do we solve homogeneous equation? So ito yung gagawin natin. We are going to use the transformation. So again, just a recall, if the degree of all terms of the ordinary differential equation is constant or the same, the ordinary differential equation is a homogeneous equation and can be solved using the transformation. Ito gagawin lang natin. We are going to put y equal to v times x. So in here, we are going to introduce a variable v. Okay, although in some books they use different letter to represent like t and lambda. Okay, here we're going to use v. And of course, if you are going to replace y by v times x, you need to also replace its differential. So along with its differential, dy is equal to v dx plus x dv. Or you can also utilize this transformation. You put x equal to v times y, and then replace your differential dx equal to v dy plus y dv, meaning you have a resulting equation having a new having variables v and y if you use this transformation. Okay, so you can use either of these transformation or these substitution. So depending on the convenience in your solution. So okay, so we are going to have examples applying these transformation. Okay, and what else? So after we have applied this transformation, our equation will actually lead us to a separable DE. So yun lang yung parang pinaka-process niya. Pag na-apply natin yung transformation, it will lead us, pag na-simplify na natin or naayos natin yung equation, it will lead us to a separable DE. So yun yung idea dito. Okay, we did substitution for us to be able to separate the variables. Okay, are you ready for our first example?
Yes
Yes,
po.
sir, we're ready. Okay, let's go. Example number 1, let's solve x squared minus x times y plus y squared dx minus x times y dy equal to 0. Okay, Now, our first step is, of course, to check if the given equation is homogeneous or not. So the criteria is that the coefficients of dx and dy should be homogeneous functions and of the same degree. So here we have x squared minus xy plus y squared. So as you can see, it's a polynomial, homogeneous polynomial degree 2, right? Kasi x squared, ito ay xy, and the last one is y squared. So the same yung degree nila. Now, para maging homogeneous equation to, our next term should be homogeneous function and degree 2 din dapat. So as you can see naman, xy degree 2, then, okay, check. This is homogeneous differential equation, right? Now, the next step will be um, what transformation to use. Are we going to uh, replace y by vx or x by v times y? Okay, so I said earlier that you can either use one of those transformations depending on the convenience of the solution. So if it happens that the number of terms of the coefficients ni dx at dy are magkaiba, okay, so merong mas madaling way ng transformation. But for uniformity purposes, for example, pareho yung number of terms nila. So ang gamitin lang natin lagi is y. Okay? We replace y by v times x. Clear ba? Pag pareho yung number of terms ng coefficients, we use y para lang maging uniform yung ating solution. But for this case, yan, obviously, we will use y equal to vx bracket. So what's the reason why we are going to use y equal to vx? So take a look at the coefficient of dx. So yung dx mo, merong 3 terms, di ba? Yung function, yung coefficient niya. 1, 2, 3. Yung dy naman has a 1 term na coefficient. So it means that since we're going to replace the differential later, dy, ano yung appropriate na variable? Y, di ba? So we replace y by vx alongside with its differential, yung dy. Clear ba tayo dito? So, bakit kaya, sir? Just imagine, di ba, kung yung x yung papalitan natin tsaka yung dx. So you have a 3-term multiplied to a 2-term, di ba, na differential. So it's quite tedious. Matrabaho siya. Compared to this one, na kapag dy yung papalitan natin, it's a 2-term differential. You have to distribute lang yung xy, di ba? So ganun lang mangyayari. So yun yung sinasabi ko na convenience sa process, sa pag-solve ng ating DE. Naintindihan ba, guys? Na-follow niyo ba? So, I hope so. So take a look at this. Now we are going to replace y by vx. Of course, if you take a differential of this, you have dy equals v dx plus x times dv. Okay, so you just copy x squared and then copy x, second term, y will be replaced by v times x plus your y squared will become the quantity v times x raised to 2 and dx, just copy this. Okay, so for your second term here, you just copy x and replace y by v times x, and your dy is actually equal to v dx plus x dv. So ito yung sinasabi ko na convenience. Imagine kung yung dx yung papalitan, so yeah, a trinomial, di ba? Multiply to a binomial. So medyo matrabaho siya. Kapag ganito lang, you just have to distribute this term here. Okay? And that's it. So ayusin lang natin. Let's just manipulate this entire equation. Let's combine like terms or let's cancel kung may common man sa kanila. Okay, so here we just multiply x times vx. So this is vx squared. Here you have v squared x squared. And here you have minus vx squared. So as you can see, common yung x squared sa bawat term. So we can divide both sides by x squared. And that we have here 1 minus v plus v squared times dx. Okay, and minus, so natanggal na yung x squared dito, naging v na lang times the quantity v dx plus x dv equal to 0. Okay, so any question here? Na-follow nyo ba yung steps natin? So basta may common dito, we can be able to eliminate that factor there. Now the next step is, of course, try to distribute this or combining like terms further. We can group this 1 minus v and distribute dx. So you have 1 minus v times dx. You have v squared dx. Distribute minus v in each term. So you have minus v squared dx. Minus v times x is you have minus vx dv equal to 0. So as you can see here, we can cancel v squared dx. And will result to this equation, 1 minus v times dx. This will be canceled. And you have minus vx dv. Okay, tandaan nyo pala ha, after you have done this substitution, dapat yung variables na involved na makikita nyo dyan sa equation mo are variables v and x. Yan, yung transformation na tinatawag natin. So pagdating dito pala, separable na yung dE natin. Okay, you can be able to separate the variables, di ba? Yung function of v na kay dv, yung function of x na kay dx. Okay, so how would you do that? You just have to divide both sides by what? So here you need pure function of x. So you divide 1 minus v. Ano yung gagawin mo? And dito naman sa second term natin, dapat pure function of v. So you divide both sides by x. Clear? So let's just have the next page para mapakita sa inyo. So before I will do that, so arrange ko muna sila. I can be able to simplify. So pwede kong interchange yung positions nito and factoring out negative. So you have negative times the quantity v minus 1. They're just the same. And knowing that, di ba, parehong negative yung bawat term. So you multiply both sides by negative para maging positive na yan. So that's why I have here minus 1. And just like what I've said earlier, so divide both sides by v minus 1 para maging pure function of x na lang to. And divide both sides by x para maging pure function of v. Clear? Now we have the equation dx over x. Now we were able to separate the variables, okay? So here you have v dv over v minus 1. Now we can integrate. So integrate dx over x. And for your second term, you have integral of v dv over v minus 1 equals the arbitrary constant c. You can actually replace this c later if you want to simplify further, or if it's possible to simplify further. Okay, now we have ln of x for this integral, and you know that we don't have a direct formula for this one unless you have devised a formula to be able to determine its integral. So here we can divide v by v minus 1. So if you divide, the answer is 1 times this, okay, v minus 1, v minus v, 0, and then minus minus, you have positive 1. So you have a remainder. So yung quotient neto is 1 plus 1 over v minus 1. So the equivalent of this ratio or rational expression is 1 plus 1 over v minus 1. So pagdating na dito, you can easily now integrate this, okay, given term. So in here, just copy ln of x as the integral of dx over x. And integrate natin yung dv. So what we did, if you're going to the last page, sorry for that. Ayan, distribute lang natin tong dv. Okay, that's why we have this. Okay, integral of dv plus integral of dv over v minus 1. Okay, clear? So we have this resulting solution. So ln of x plus v plus ln of v minus 1 equals ln of c. Bakit naging ln of c? Para masimplify natin, matanggal natin tong ln dito. Okay, although one of the terms here, hindi naman siya naka-ln, but majority of the terms are naka-ln. Kaya we put c into ln of c to simplify further. Now we can combine or we can rewrite, ln of x plus ln of v minus 1 into a property, okay, following the property of logarithmic functions or ln, natural logarithm. So you have ln of x times v minus 1 plus v. Okay, and then we can perform the anti-ln, so e raised to the entire left-hand side of the equation. Okay, so this means that e raised to ln of x times v minus 1 times e raised to v. Ganun yung kalalabasan niyan. That's why we can be able to eliminate here ln giving us x times v minus 1 times e raised to v. On your right-hand side, so e raised to ln of c will give us the arbitrary constant c. Now, this is not yet our final answer since we did a transformation or substitution. So we need to bring back the original variable na x and y. So dapat you have to replace now the variable v here by its original equivalent. So you know that y is equal to v times x. Then v is equal to y over x. So you plug it in here. That's why you have x times v is equal to what? Yan, y over x minus 1. And then you put this into one fraction. So you have y minus x over x. You can cancel x, right? That's why you have this final answer, y minus x times e raised to y over x equal to c. Okay, that's it. So any question? None. Silence means no question, sir. Okay, na-follow nyo ba, guys?
Medyo po.
Medyo lang. May clarification po ba? Okay, wala naman. Okay, let's see. May nag-chat. Sir, paano po pag sinimplify yung y over x? Tamang sagot pa rin po ba yun? Okay. Y over x. Saang line ka lang banda? Pag ganun. Hanggang dito ka lang ba? Or where? Ay, baba po bago mag-answer. Ito ba? Ganito lang. Lang kausap. Okay. So, kailangan as much as possible, mas-simplify mo talaga siya. Okay? Madaming mga ganyang cases. Nakala mo simplified na yung sagot pero pwede pa pala. Okay, may maka-cancel ka pa. Okay, so any more questions? None. Let's now proceed to example number 2. So we have, okay, x times y dx plus x squared plus y squared times dy equals 0. So, ayan. Looks so simple. Pero yung idea naman kasi nito is para magamit natin yung other na transformation. Okay, as you can see, okay, degree 2 yung ating first term. Our second term is a homogeneous function din, di ba? Degree 2. So dahil sa the same yung degree in each term, then this is a homogeneous differential equation. Are we clear with homogeneous equation, yung kanyang definition? Or paano malaman na homogeneous equation siya?
Opo.
Clear na tayo dyan. Okay, kasi hindi lang ganito kasimple yung mga ma-encounter nyo later, di ba? So if you have checked the problem set, pag nasanay na kayo, makakita nyo kaagad na, okay, homogeneous function siya. So gawin nyo yung practice kanina, yung kanina earlier natin na example for homogeneity. So yun yung isa sa mga technique para malaman mo na homogeneous functions siya. Okay, so here, the more convenient way here for your transformation is by putting x equal to v times y. Why is that? Kasi if you can see this one, yung dx natin has only one term na coefficient, right? Yung ating dy has two terms. So it's more convenient to replace, of course, x by vy kasi you have to replace yung differential din. Kaya magkakaroon ka ng dalawang terms dito sa first term. Nakuha ba yung punto ko dito? I mean, yung point dito ng pagpili ng magiging substitution. Pero nabanggit ko kanina na kapag pareho yung number of terms, okay, let me just write something. Okay, katulad nito. So if you encounter, diba, 2x plus 3y, okay, yan, times dx. Tapos, yung next term mo naman is, for example, 3 x plus yan, 2y dy equal to 0. Yan. So dalawang number of terms, parehong homogeneous functions. So sinabi ko kanina na for uniformity purposes, we will use y equal to vx. Okay? Yun ang gagamitin natin. Nakuha ba? Kung tatlong terms, y is equal to vx. Okay, hindi ko sinasabi na yung x equal to vy, mali. Para lang kapag nag-compare ako ng sagot ko sa inyo. So, hindi na ako mahirapan. Okay, for convenience din. Clear ba tayo dyan, guys? Para pag nag-compare kayo ng mga sagot nyo ng classmates mo sa problem set, pareho kayo ng, I mean, kalalabas. Although na, pag in-apply mo na yung mga conditions, it will lead you to the same answer if it's particular solution yung hinahanap. Okay na ba, guys?
Sir, magka-come up lang naman po 'di ba sa same answer?
Yeah. May mga instance kasi
Either po
na
sa X and Y.
hindi sila pareho ng sagot. Pero pag in-apply mo na, kasi nga 'di ba, there are many possible solutions kapag DE. Okay? Like pag-integrate mo kunyari yung ln of pag-integrate mo yung mga trigo functions, meron kasi na 'di ba iba yung sagot, like for example, um, tangent, 'di ba? Integral ng tangent. Ano yung integral ng tangent? Integral ng tangent. ln of negative ln of cosine, or pwede rin kasing ln of secant, 'di ba? So yun yung dalawang possibilities. So parang ganun yung idea na kapag magkaiba tayo ng transformation, so maaring iba yung representation dun sa final answer. Okay? Nakuha?
Yes po. Thank you po.
Okay, so next step natin dito is that you're going to apply now these transformation here. Ang ibig sabihin nito, ang kalalabasan na equation natin will contain variables. Ang makikita mo lang sa equation dyan is variables v and y. Wala ka na dapat x na makita dyan. Okay, so let's be clear about that. Na pagdating dito, we'll simplify. So just copy here y is equal to y times v times, yung x papalitan ng vy eh. And your dx will be replaced by v dy plus y dv. Ganun din dito, x squared will become v squared y squared, and you just copy y squared, copy dy. We arrange our equation, or we multiply this one, we have vy squared. And here, mapapansin mo na ba na common yung y squared dito? Well, you can actually eliminate y squared by dividing both sides by y squared. At ang resulting natin na equation will become v times this sum, v dy plus y dv. And in this term, you have v squared plus 1 times dy. Okay, so again, it will lead us to a separable d pag inayos na natin siya. So here, we are going to distribute v in each term para makombine natin yung like terms kung meron man. So this becomes v squared d times dy. This becomes vy dv. And here, v squared dy and dy. So as you can see, mayroon kang, ayan, tatlong terms actually yung dy, di ba? Ito, isang term lang yung dv mo. So you just copy this one, combine these two terms, magiging 2v squared siya. 2v squared plus 1 pag pinactor out mo na yung dy. Okay? Now, pwede mo na i-separate yung variables na maging pure function of v na lang itong term na to by dividing both sides by y. And here, maging pure function of y to by dividing both sides by 2v squared plus 1. Kaya ito na yung resulting equation natin. We integrate each term. So we have, this is ln, provided that the numerator is the differential of your denominator. So if you differentiate this, 2 times 2, it's 4v dv. Eh, ang nasa numerator mo lang is v dv, di ba? So you have to introduce a neutralizing factor. So meron kang 4 dito, and then you divide outside by 4 para masatisfy natin yung formula for ln. And here you have, dy over y, it's just ln. Then we have this solution, 1/4 ln of 2v squared plus 1 plus ln of y equals, okay, anong ginawa natin sa c? We can transform c din para ma-simplify natin yung solution. Since common, di ba, in each term yung ln, and we don't want, di ba, a fraction or constant na 1/4 dito. So kaya may 1/4 na rin tayo dito. And then we multiply both sides by 4 para matanggal natin yung 1/4 dito. Pero magkaroon ka naman ng 4 na coefficient sa second term mo. So 4 ln of y equal to ln of c. So what happens here, para makombine mo yung dalawang terms na to in your left-hand side, you have to put yung 4 as the power of your argument here. Magiging y raised to 4 na siya. If you see this one. Yeah, ito na yung sinasabi ko. Para makombine natin silang dalawa, so this becomes ln of 2v squared plus 1 times y raised to 4 equal to ln of c. So to remove ln, so we are going to apply or to take the anti-ln for both sides of the equation. That's why we have this product. Okay, this product na 2v squared plus 1 times y raised to 4 equal to, you know that e raised to ln of c is equal to c. Okay, na-follow nyo guys? So in this part of your solution, hindi pa to yung final answer because you still have the variable v. So recall that x is equal to v times y, then v is equal to x over y. So if you're going to replace now or plug in here the value of v, magiging ano siya guys, quantity x over y raised to 2 magiging x squared over y squared. And pagsamahin sa isang fraction, so magiging 2x squared y squared siya. Itong 1, y squared over y squared. So pag parehong denominator, you can actually combine them. So 2x squared plus y squared over y squared. And you have here y raised to 4 kasama sa product nito. So y raised to 4 divided by y squared is equal to y squared. Okay, so that's it. Yun yung ating solution. Wala nang variable v dyan. So it's check. Questions, clarifications, violent reactions? Going once, twice, none. Okay, no questions. Maaga tayong matatapos. Thank God. Let's now go to, oh, what happened here? Ito yung link ko sa YouTube yata. Let's do this. Example number 3, let's solve a particular solution. So, can you see this one, guys? Solve x dx plus y sine of y over x dx minus x sine of y over x dy equal to 0. May condition tayo dito since we are after, fighting for the particular solution. When x is equal to 1, y is equal to 0. Ang ibig sabihin itong ating condition. Now, the question is, homogeneous equation ba ito or not? So if you're going to arrange this equation, ayan, since common yung dx dito, inayos ko lang para makita mo. Nasa form siya na mdx plus ndy. Okay, so what I did here, I factored out dx. So you can see x plus y sine of y over x. So determining the degree of this function, yeah, homogeneous to kasi pag in-apply mo yung lambda dito sa fraction or sa ratio na to na y over x, makancel lang yung lambda. So that is, or this trigo function is a homogeneous function. Clear? So degree 1 siya and yung x mo is degree 1. So ibig sabihin, the coefficient of dx is homogeneous function degree 1. Now take a look at the coefficient of dy. Sine of y over x is homogeneous function din. Tapos yung x will give us degree 1, di ba, for this coefficient of dy. Okay? Nasundan ba, guys? Now, ano yung appropriate natin na transformation dito? Are we going to use x equal to vy or y equal to vx? Anyone?
Y is equal to Vx, sir.
Y is equal to vx. Bakit?
Isa lang po yung term ng dy.
Very good. Okay, kasi isa lang yung term ng coefficient. Isang term lang yung coefficient ni dy, kaya y is equal to vx. Okay, clear na tayo dito. So we are going to use y equal to vx. Of course, we have to replace the differential na v dx na dy is equal to v dx plus x dv. And pwede na natin palitan na ito kaagad, di ba? Kasi pag in-apply mo na yung y equal to vx dito, makancel lang yung x, di ba? Or you can simply say v is equal to y over x, right? So instead of writing here vx, palitan mo na kaagad ng v yan. Okay, kasi ang after naman natin is yung resulting equation natin will contain variables v and x. Clear? So kung saan ka masaya, you can actually apply vx here, makancel mo yung x dito sa ating argument ni sine. Vx here, makancel mo yung x, or just simply write v na lang. Nakuha ba, guys, yung point ko? Kasi ang ginawa ko dito, ayan na. So x dx, given tong equation natin. Tapos yung y ko, naging vx. Yung y over x ko, naging v na lang siya. Okay? Sine of v dx. Ganun din dito sa second term natin. So copy ko lang yung x. Sine of y over x is equal to v. Tapos yung dy natin is v dx plus x dv. Now, I will distribute this function in each term here in your second term. That's why I will have, ayan, v times x minus yung sine ha, sine v dx. And this one, negative times positive is negative. X times x, we have x squared, sine of v dv. Okay, clear na? At may makita ka ditong like term. So usually kapag may mga unlike signs dyan, may makakancel ka kaagad dyan. Or kapag kapareho man yung sign nila, meron kang mapag-a-add dyan. Okay, so makakancel na natin yung itong vx sine v dx. Ang matitira dito is x dx minus x squared sine of v dv. Okay, clear? Now, separable na siya, di ba? Yun lagi yung kalalabasan niya. Pag gawa na natin yung transformation na ayos na natin siya, we can separate the variables. Okay, dividing both sides by, we don't want x squared here. So pag divided both sides by x squared, ano mangyayari? Magiging dx over x na siya sa first term kasi makancel natin yung x. And for the second term naman, sine v dv. Okay, pure function of x and pure function of v. Okay, so the next page here, we can integrate each term. Ln of x yung sagot dun sa integral ng dx over x. Now, recall the antiderivative of sine of v. It's negative cosine, right? Tama ba? Kamali ako. Kasi kapag derivative, di ba? Derivative ni cosine is negative sine. So kapag sine na may integrate natin, magiging negative cosine. Okay, so negative times negative, you have a positive. Okay, here in the middle, so ln of x plus cosine of v equal to c. Now, this is not your final answer. So hindi mo na kailangan pang gawing ln ito. Okay, since isa lang naman yung term natin. Tsaka yung x naman na variable natin is the independent variable. Pag pinag-usapan yung variables x and y, x is independent variable. So we replace v by y over x. That's why we have this. Ln of x cosine of y over x equal to the arbitrary constant c. Meron tayong condition. So we need to determine ano yung value ni c. Applying the condition, di ba sabi kanina dun sa condition, when x is equal to 1, y equals 0. Okay, so apply natin dito, ln of 1 is 0. And cosine of, di ba, 0 divided by 1 is 0. So cosine of 0 is equal to 1. That's why yung ating c is equal to 1. And then replace c by 1. And our final answer will be ln of x plus cosine y over x equals 1. Okay? Unless pag tinanong ka, diba, solve for y. So kapag ganun yung mangyayari, so transpose lang natin to and then our cosine. Okay? Pero, yan, bihira sa ganung cases. Okay, I think we're good. Any more questions, guys? Or any questions? Clarifications?
Sir, tanong lang po.
Sure.
Yung sa degree po na sin y over x, paano po naging 1 po yung degree doon?
Saan? Saan?
Sa equation po na ano?
Example ba to? Example natin?
Opo, sa example. Diyan.
Ito.
Opo, sin over x. Paano po naging 1 yung degree?
Degree 1. Okay, ano yung degree ng x? Exponent ni x. 1, di ba? Exponent ni y.
1 din po.
1. Bakit? Kasi dito sa sine of y over x, makancel mo yung lambda, di ba? Ganon. So, yan. Ito yung basihan mo, yung y dito. So, 1, 1. Dito, 1. Tapos, yung lambda mo dyan, makakancel mo kapag in-apply mo ng lambda. Right?
Thank you po, sir.
Na, nakuha ba?
Opo, sir.
Kaya siya naging degree 1. Kung wala itong x na to, degree 0 yon. Nakuha? Kung wala yung x, degree 0 yan. Kung wala yung y, degree 0 to. Homogeneous function, degree 0. Clear? Okay. Because of this x and this y here, degree 1 siya. Okay, any other questions, guys? Okay, sige, dahil wala na kayong tanong, let me just give an announcement. So, meron pa tayong kasunod nitong topic. So, this week is a special na week because prelim period, di ba? So, encoding ng prelim namin. So, on Friday, I'll be, hopefully I can be able to finish the encoding. Para Friday, I can show you your prelim grade, pero it will not be finalized yet. So, sa hapon pa ako mag-finalize. Just to make sure na kung merong clarification dun sa scores ninyo or if you have any questions about the quiz, the prelim exam. So I can be able to accommodate and update your scores kung meron mang mga meron mang kayong mga corrections. Okay? So on Friday, so we will have a class on Friday. But if you're not available on Friday, it's okay kasi yung klase naman natin will be recorded. It will be a 30-minute na lecture. I'll be explaining this topic. Or hopefully I can be able to solve more examples or can be able to record a video showing more examples for this topic. So our topic for Friday will be coefficients linear in the two variables. So another transformation. Anong itsura ng case na to? So ito yung may coefficient na linear. Okay? Or line. Diba? Pag i-equate mo sa 0, equation ng line na to, di ba? A sub 1x, B sub 1y, C sub 1. A sub 1, B sub 1, C sub 1, A sub 2, B sub 2, C sub 2. These are constants. Okay? So ito naman yung magiging topic natin for Friday. Again, this is not a required class. Hindi kayo required na umattend. But if you're available, okay, please, you may attend. Special week naman to eh. So hindi naman ito lagi nangyayari. Okay lang ba? Hindi kayo magagalit. So on Friday, so I'll be posting a link para sa Zoom meeting on Friday. Okay ba? Wala akong naririnig na response. Anyway.
Opo.
So yun, kung may mga questions kayo dun sa grade ninyo or kasi papakita ko yung grade ninyo. Kung hindi kayo makaka-attend, so you can't be able to, ask for clarification. Or pwede kayo mag-message sa akin, but hindi ganun ka-active ngayon sa because of the busy schedule for encoding ngayong week. Okay, so yun yung opportunity niyo to ask questions. So you will be put into a breakout room and then I'll be calling you one by one. Okay, let me just stop sharing this one. Okay, let me just